Hi Ram, good morning.
Good morning, sir.
Yeah. Till where we have completed, can you just remind me? Till what we have done last on Wednesday? Uh, Actually, I'm not getting any time to upload the notes and the homework. I will do it today because I don't have any classes today. Okay. Mhm. Have we have completed what? We have completed the limiting reagent part.
Molarity of mixing of two same solutions.
Molarity was also done.
Yes, sir.
Have I discussed mole fraction with you?
Yes, sir.
Mole fraction was also discussed.
Yes, sir.
Okay. So are these notes yours? Might be, I guess. Okay. Yes. Then the next topic we have to start with, it's titration. Where is this guy? This fellow wants to join or no?
Hello.
Hi, Mrinal.
Yes, sir. Yes, sir. I'm joining.
Okay, okay. So shall I start?
Yes, sir.
Okay. Can you see the screen now? Yeah. Okay. So the topic is effect of temperature on concentration. What is the effect of temperature on concentration? So what happens usually is that on increasing the concentration, on increasing the temperature, our concentration also increases. Just remember this thing. That for us, this is the only thing we should know about the temperature effect. Okay, which concentration term will be increased? Of course, molarity will have this effect. The terms which are related to volume, which contains volume in them, they will be definitely affected with temperature. Molarity will be affected, but mole fraction will not be affected. Okay, mole fraction will not be affected with the change in temperature. I hope this is clear to you, right? So now we are at a stage that I can teach you the titration part. Okay, titrations. What are titrations? What are titrations? Any one of you, do you know what are titrations? Any idea? Any small idea you have about titrations?
Yes, sir. Acid-based titrations.
That only I'm asking. So, what are they? What are you doing? What are you trying to find out in that?
Molarity of base or acid.
Yeah, molarity of any unknown solution. So, how titration works is we take a conical flask and we have, let's say, let me assume that I have added here an unknown concentration solution of acid whose volume I know. Let us say the concentration is M1. The volume which I have added over here, this I know, which is V1. It is known to us. Okay, let's say 10 ml I have added for this. Okay. Then what I will be doing is I want to find out this M1 value. What is this? I don't know, but I want to find out this. Okay. So what I tried, I will say that, okay, I will be keeping here a burette. This is called a burette in which there are lines, marks of the volume in centimeter cubes. Okay. Like it's like 1 centimeter cube, 2 centimeter cube, 3 centimeter cube, 4 centimeter cube, 5 centimeter cube, like this. There are marks. And in this burette, I am having base of known concentration. The concentration of this base we know. Let's say this is M2, but we know it. Okay. So now, what titration does is it tells you about the value of M1. Somehow it tells you the value of M1. How? See, as soon as I add my base into my acid solution, think what will happen. Sir, we are studying this from our class 10th or grade 10 that whenever you add any acid and treat it with some base, it will give me salt plus water. This will form, let's say, right? Definitely, sir. Definitely. So when your HCl will be finished, when it will be reacted with some equal amounts of NaOH, because you know that stoichiometry is same, right? So the amounts of HCl and NaOH, the moles of HCl and NaOH which are required here should be same. Do you agree with me in this part also? So what I'm trying to do is, I know that how much volume of HCl I have taken or acid I have taken, which is 10 ml. And I am adding drop by drop. From this burette, I am adding my base. So what is happening in the reaction mixture? It's the acid will be reacting with your base to produce your water and your salt. Okay. But now, when these will be finished, let's say you are having some, let's say you have taken some 0.5 moles of this, 0.5 moles of this. Let us assume that. So when these 0.5 moles will be reacting with the 0.5 moles of NaOH or any base, 0.5 moles of acid will be reacting with any moles of base, then the reaction will be completed, right? Then definitely the reaction will be completed. So the question comes here, then that how will you see from your eyes that the reaction is getting completed? Because we don't know when should I stop my addition of base. Are you getting this point? See, I am adding my base continuously from the burette. From here, from here, I am adding my base continuously. It is coming drop by drop by drop. It is coming over here. It is already HCl solution over here. I'm adding drop by drop by drop. Till what time, till what volume of base shall I add? We have to add the base till your reaction is completed. But who will tell me? Or when will I know when is my reaction getting completed? So this is the work of indicator. This is the work of indicator. So we are also adding an indicator. What is the meaning of indicator? The indicator is added in very, very small amounts. Let's say uh, 1 to 2 drops just. Okay, 1 to 2 drops you can add just, or 2 to 3 drops you can add about for an indicator in this conical flask. Okay. Now what happens is when you are only having the acid solution, indicator will be having some color. I said, okay. Then when you just start adding base from the top, from the burette, like because we know that acid plus base will react together, so the amount of acid will decrease. Yes, of course, it will decrease. And once this acid is completely finished, what will happen? Only the base will left. Like I'm adding drop by drop, right? I'm adding my base drop by drop. So I just added one more drop and I got some change in color in this conical flask. Getting my point? Okay. Previously, the conical flask has some different color, which was due to the presence of indicator. Now, I am saying you that okay, let us assume that your reaction is completed. Your HCl is completely reacted with NaOH. Okay. I just added one more drop of NaOH and this conical flask color has changed. The color of the solution in the conical flask has completely changed. What it was before, it is not that. It has completely changed. And that is the point that the indicator tells you. That is my point where your this reaction is completed. So basically, indicator gives you the idea of the end point. What do we mean by end point? End point means at what volume of the base from the burette which you have added is my reaction is going for completion. Getting this? What is the end point? Indicator tells you about endpoint, okay? Endpoint is that point at which volume, at what volume I will say, at what volume indicator changes color. And indicator will change color only if the reaction is completed. The reaction is completed. So what I did, it gives us the volume of the burette. Volume of the burette. That how much volume we have added from the burette up till now. Is it okay for you? See, now we are having four terms. What four terms? I want to find this M1. I want to find my concentration of acid, let's say. I have the volume of acid known. I know the concentration of my base as well, which is M2. But I didn't know how much volume I was using for the base for the complete reaction, right? But because of the presence of indicator tells me, yeah, okay, stop adding the base. Reaction is done. Please don't add any more base. So that thing indicator tell me, and this volume will be, let's say, V2. Whatever the volume burette reading is showing to you, na, that volume is V2. Is it okay for you? Fine. Please
Yes, yes, sir.
give it some. Sorry, Gram.
Yes, sir.
Okay, clear then. Okay. So what happens? Okay, let's say I will tell you, okay, if I am having HCl as 0.2 molar concentration. Okay, let us say that I have to find it. Okay, what is the concentration of HCl? I don't know. I said that okay, I am taking 10 ml of HCl. Okay, and in the burette I am taking NaOH whose concentration is 0.2 molar, and the burette reading shows the burette reading shows that 25 centimeter cube of NaOH was required to completely neutralize HCl, because this reaction, acid plus base reaction, is also called a neutralization reaction. So they will write a statement that 25 centimeter cube of 0.2 molar NaOH was required to completely neutralize 10 centimeter cube. I will write here 10 centimeter cube of HCl. I hope this is clear. So find the concentration or the molarity of HCl. That will be your question finally. Is it okay for you? Can you do it? Can you do it for me? Just very fast. Quick, quick, quick. How can we do it? Can I use M1 V1 is equal to M2 V2 here? Can I? One molarity is given to you, volume, both volumes are given to you. I want to find a new molarity. Can I use that here?
Yes, sir.
No. No. For this case, it will be valid. Listen to me carefully. For this case, it will be valid, but not for every case. What is the primary purpose of titration? Do you know that? What is the primary purpose of titration? Primary purpose of titration is that you are equating number of moles of H plus with number of moles of OH minus. Put it in box, note it down. This is titration. This is the actual meaning of titration. This is titration. That your H plus moles should be equal to OH minus moles at the end point. And titration gives you that end point. And when this is equal, when they becomes equal, your reaction is finished. The reaction is completed. Think this way. Clear? Okay? When these two are equal, the moles of H plus and the moles of OH minus, whenever they are equal, your reaction is completed then. This is the purpose of titration. You will be feeling it after a little more time. You will be feeling this thing. Okay? So if I ask you, can you, if we have to equate the both the moles, can we do it here as well for this question? Can you find the answer then? If both the moles, I'm saying the moles of the H plus and the moles of the OH minus are equal, can you tell me the answer? Okay, do you know one thing? I will tell first ask you this thing. Do you know one thing that HCl is an acid which in water will get dissociated into H plus ions and Cl minus ions because it's a strong acid. NaOH is a strong base. So in water it will also get dissociated into Na plus OH minus ions. Now they are saying that we are having 0.2 molar NaOH. So how much Na plus you will get and how much OH minus you will get? If I ask you, how much you will get these quantities? Can you tell me quickly? If I am taking 0.2 molar of NaOH, how much my Na plus and OH minus should be? According to the stoichiometry, see na? If they are getting broken down in the presence of water, how much you are getting your Na plus ion, how much you are getting your OH minus ion? Please tell fast. Hello, hello, are you guys there? Or you are sleeping?
0.1 and 0.1.
0.1 and 0.1. No, never. It's not like that. See, you are having stoichiometry 1 is to 1 is to 1. So whatever the concentration we are having here, the same concentration Na plus will be having, the same concentration OH minus will also be having. Is it okay? Both will be in the same amount, same concentration both will be having, Na plus also, OH minus also. Okay? That is how stoichiometry works, isn't it? That's how stoichiometry works. That's why we have learned stoichiometry before. Mrinal, are you fine with this?
Yes, sir.
Okay, fine then. So let's say that now we know that how much OH minus concentration I am having. And I know the volume of the NaOH as well, which is 25 centimeter cube. So can I get the moles of OH minus? Can I? Yes, we can get the moles of OH minus very easily from here. N of OH minus will be nothing but molarity of OH minus ions into volume of OH minus ions. Molarity of OH minus ions is nothing but 0.2. Volume of OH minus ions is nothing but 25 centimeter cube. And I have to convert it into decimeter cube, so I am dividing it by 1000. So this is my number of moles of OH minus. I said, okay, fine. Do you agree with me? This is fine, right? Now, what will be number of moles of H plus? Number of moles of H plus will be that molarity of H plus into volume of H plus. So do I know the molarity of H plus? No, I have to find molarity of H plus. And what is the volume of H plus? 10 centimeter cube. But again, I have to convert it into decimeter cubes. So I'm dividing it by 1000. So now I can equate them because titration, basic principle of titration is this, that moles of H plus should be equal to moles of OH minus, right? So just equate them. You'll be getting what? M of H plus into 10 will be equal to zero point 0.2 into 25. I have already cancelled out 1000 and 1000. Okay. So this will give you molarity of H plus as 0.2 into 25 divided by 10, which is nothing but how much? 0.2. How much you will get? 5 by 10. 0.5. This is the answer. 0.5 molar will be the concentration of H plus ions in the solution. Is it the concentration of HCl? I don't know. I don't know if it is the concentration of HCl or not. I don't know this. See, what we got right now, we got the concentration of H plus, which is this value. This value I got as 0.5 molar. Is this having the same stoichiometry as HCl? Yes, sir. This is having same stoichiometry as HCl. That means if this is 0.5 molar, then this should also be 0.5 molar. That is how you are calculating the concentration of acid required. Is this clear to you?
Yes, sir.
100% both of you? The titration questions are very, very common in the exam. This is the basic principle of titration which you have to use for acid-base titrations. Okay, NH plus should be equal to NOH minus. I am not saying acid moles will be equal to base moles. No, acid moles are not equal to base moles. I am saying moles of H plus should be equal to moles of OH minus. And how we are getting that H plus and OH minus? When you are dissociating this acid, when you are dissociating this base in the presence of your aqueous medium. We know now whenever you add something in water, either it's a salt or it's a acid or it's a base, it will get dissociated into its ions, which is happening over here. Okay, so if this is clear to you, I want to give you one question. Please try it. Let me say that we are having 20 ml of H2SO4 was added in a conical flask containing phenolphthalein phenolphthalein indicator. The the titration was done. The titration was done with 0.5 molar of NaOH solution, and the end point was reached at 30 ml. What is the concentration of H2SO4? This is your question. Can you try it? Any help you require, please ask me. Remember the basic purpose. Okay, when you will be using the titration concept, whenever you are finding one acid, one base. Acid base reactions if they are going together, it's a titration question. Think. Think this way. First, I am having so many questions right now with me. Do it. So how you are doing? Please interact with me. Let's do it together here.
So 0.37.
Is the final answer?
Yes, sir.
So you are saying the concentration of H2SO4 is coming out to be 0.37 molar. Yes?
Yes, sir.
Let me try it with you then. So see, what you have done is you have equated again NH plus is equal to NOH minus, right? Okay. So what is the okay? First of all, we have to write the equations for H2SO4. How will it be dissociated? It will be dissociated into 2H plus SO4 2 minus. I said okay. And then NaOH is there, it will be dissociated into Na plus OH minus. Okay, do you have some concentration? Yes, NaOH concentration is given to me as 0.5 molar. So this will be 0.5 molar again. This will be also 0.5 molar again, right? So I'll be having concentration of OH minus as 0.5 molar. And what is the volume of NaOH do I have? 30 ml. So number of moles can be calculated by molarity into volume. So it will be 0.5 into 30. Okay, divided by 1000 I will do. And N of H plus. So H plus concentration I am not having right now. This is question mark. But I know the volume of HCl, which is 20 ml. So okay, we will take 20 divided by 1000. But I don't know the concentration of H plus. I don't know it. Okay, we'll find out then. What is M of H plus coming out to be? So this will be cancelled. Zero point 0.5 into 30 is how much? 0.5 into 30 is how much? 5 threes are 15. 15 by 20. 3 by 4? Are you getting 0.75 for molarity of H plus or the concentration of H plus? Tell me.
Yes, sir.
Okay. Then, sir, we have to look. See, now you got the concentration of H plus from here, which is 0.75. And you know the stoichiometry is 1:2. So if this is 0.75 molar, then what it will be? The half of it? Yes, 0.75 by 2, which is it 0.37 something? 0.375?
Yes, sir.
0.375. Okay. I hope this is clear to you guys. Mrinal, any doubts? Mrinal, hello, hello. Any doubts you have? Your voice was not coming if you're saying something. No, it's still not coming. You can give me some emojis or something then. Oh, he left. Okay, till the time I will be writing some other question for you. See how the AP asks you a question, Ram. A non-carbonated soft drink contains an unknown amount of citric acid. Formula is also given to you as H3C6H5O7. If 100 ml of the soft drink requires 33.51 ml of 0.0102 molar NaOH to neutralize the citric acid. To neutralize the citric acid completely, then how many grams of citric acid does the soft drink contains? Does the soft drink contains per 100 ml, per 100 ml, the reaction is given to you as H3C6H5O7 plus 3 NaOH gives you Na3C6H5O7 plus 3 water molecules. This. Try it. Where is this guy at? Trying na?
Yes, sir. Trying, sir. I mean,
Okay.
so 0.065.
This is the final concentration you got?
Yes, sir.
Let me check the answer. Wait. Hmm. How much you said?
0.065.
This is what? Moles or what?
Mass of the citric acid.
No, I am not getting this answer.
I'll try again.
See, where have you done some calculation mistake or something? Is it?
Sir, I can't understand the part 100 ml of the soft drink.
The last part.
Yes, sir. Like, how should we use the 100 ml?
Okay, so what concentration of citric acid you got? Can you tell me that first? Concentration you got, na? Something for the citric acid?
I didn't get the question, sir. I did it in the wrong way. So,
Oh, see, it's the same kind of question only. See, a non-carbonated soft drink contains an unknown amount of citric acid. One acid is given to you. Okay. They have taken 100 ml of that acid. They are mentioning it, and it's 100 ml of the soft drink which they are taking, which requires 33.51 ml of 0.0102 molar solution of NaOH. So it's the same thing. One base is given to us, one acid is given to us. What is our purpose? Use the titration concept. Number of moles of H plus will be equal to number of moles of OH minus, right? So I can get the number of moles of OH minus from here, and I will be equating that to the number of moles of H plus. So find the number of moles of H plus first, or whatever. You can find the molarity of H plus as well. Is it okay? That is clear?
yes, sir.
Okay. If you can find the molarity of HCl, or sorry, the molarity of your acid. So what is the acid? Acid is H3C6H5O7. So if I ask you H3C6H5O7 will be in aqueous medium, it will be dissociated into what? In aqueous media, it will be dissociated into 3 H plus ions plus C6H5O7 3 minus. Do you agree with me? Because it has 3 H plus. Yes? We will be when I equated NH plus with NOH minus, I might be getting here MH plus value. Which what value you got from here? Can you tell me that one? When you equated both of them together, or shall I do it? Okay. So
I
N.
didn't get anything, sir.
Okay. So let's say N of OH minus. Can we find it out using molarity times volume? That we can do. You can unmute
Yes,
yourself.
sir.
That we can do, right? So
Yes, sir.
molarity is what? It is given to us as 0.0102. And what is the volume? 33.51 centimeter cube divided by 1000. And then N of H plus, how will I find that N of H plus? It will be the volume of H plus, which is given to as 100 ml divided by 1000. And then molarity of H plus, which I don't know. So can you find it out from here? 1000 will be cancelled out. Can you do it? Can you do this calculation for me? M of H plus.
Yes, sir.
Okay.
0.00342, sir.
0.00342. Okay, let's say this is my concentration of H plus which I am getting, isn't it? Then this is this value, that means. This value is this value, 0.00342 molar. Now we now can I now find out the concentration of my acid as well by just checking the stoichiometries?
Yes, sir.
So how much it will be? 1 by 3 times of this, or just divided by 3?
Divided by 3, sir.
Yeah, divided by 3. So whatever the value you are getting, you just divide it by 3. The 0.00342 divided by 3, how much? 0.00114. 0.00114. Is it okay? So
Yes,
this is
sir.
the concentration of citric acid which you have got here, right? Okay. Now, what do you want to find? You want to find out how many grams of citric acid is there. Okay. So because I know the concentration now, can I first find the moles? And from the moles, I will use the Y map to find the grams. Do you agree?
Yes, sir.
Okay, so let's quickly find out the moles. So moles of citric acid. Moles of citric acid will be how much? It will be 0.00114 into volume. 100 ml, na? So you have to divide it by 1000 as well. Is it okay? In this way, we will be able to find it out. So moles will be 0.000114. These will be the moles of citric acid. I hope this is clear to you, right? And then if I want to find the mass of citric acid in grams, It will be just multiply these moles by the molar mass according to the Y map, you know it. So molecular mass of citric acid is what? Molecular mass of citric acid is what? You have to find it out from here.
192, sir.
Sorry?
192.
192. Multiply this value by 192 then. 0.000114 into 192. Check. How much you are getting? I think you should get 0.02198 something grams.
Yes, sir.
Yeah, if you are getting
0.02189.
0.02189. Okay, 89. It's fine. No issue. 89. Whatever. Something like this value. Yeah, this is correct. And approximately 0.022 I am getting. Isn't it? 0.022
Yes,
grams.
sir. Sir, if
That is,
it is a FRQ, should we write 0.02189?
you have to think here. Now, how much significant figures they have mentioned you? See here, how much are there in this question? Here we are having three significant figures, right?
Yes, sir.
Here we are having four significant figures. Here I am having how many? Just one? Yes, just one significant.
1.
Yeah. So we have to report the final answer in one significant figure itself. That means up to 0.02 only. It's enough. 0.02.
Okay,
Okay.
sir. Okay, sir.
So this is how we can solve. So where was your mistake? Are you able to identify your mistake? How I approached the question and how you were approaching the question maybe? Did you identify your mistake here?
Yes, sir.
Okay. Okay, cool then. Uh, Now he will join or not. He has some network issues. I don't know. Okay then. One more request I want to make. Maybe we have to shift this Friday's chemistry class to some other day. Is it possible for you?
It's okay, sir.
It's okay.
Yes, sir.
So maybe okay. Can we have two classes on Monday? Is it fine if you are okay with this or no?
Like what, sir? Time.
Time one class we are already having at 8 to 9, right?
Yes, sir.
You can decide any other time. Maybe anytime it's fine. Maybe some morning slot if you want to take 10 to 11, 11 to 12.
Morning, it's okay, sir.
Mornings are okay?
Yes, sir. Evening, but evening it starts.
Okay, okay, no issue. Then maybe any morning time if you want you can give. Or maybe what I can do, sometimes we will have Monday two classes, sometimes I can take another class on Tuesday. So Monday, Tuesday, Wednesday we will be having consecutive classes or Monday two, Wednesday one. It's fine.
Yes, sir.
Good. Good. From your side, it's okay then. Okay, then I will be giving you some more questions. You try to do that. See. What kind of rubbish question they have asked one time. They're saying some potassium dichromate K2Cr2O7, which is 2.335 grams, is dissolved in enough water to make exactly 500 ml of solution. Okay. What is the molarity of K2Cr2O7? That is your first question. What is the molarity of this? And what molar concentrations are of K plus and Cr2O7 2 minus? You have to tell me the answer of this first. Very easy question. It's not a difficult question. Find quickly.
So mass number of potassium.
Oh, 39.
Okay.
Chromium, you know?
Don't know, sir.
Okay, mass number of chromium is
Sir, if they will provide the mass numbers, no, sir, in an exam.
definitely they will provide it. 52.
Like Planck's constant also.
They will give it. They will give it.
Okay, sir. Nothing to memorize, no, sir.
No. Yeah, reach some conclusion for the concentration of K2Cr2O7 first.
Sir, 2 into 10 power minus 5, sir, molarity. Molarity.
Okay, I am not calculating it as such. I will be just asking you the what is the molar mass you have taken here?
292, sir.
292. Okay, so you divided by this. This is the
Yes,
number
sir.
of moles you got. You divided by the volume also 500, but in decimeter cubes or liters you have to put. So divided by 1000 as well. This is the final answer which you'll be getting for K2Cr2O7. Do you agree?
Yes, sir. Then
As the
it's
concentration.
2 into 10 power minus 2.
2 into 10 to the power minus 2
Yes, sir.
molar. Okay, it's fine. Then K2Cr2O7, if you try to dissolve it in water, in what substance it will break? It will break into 2 K plus ion plus Cr2O7, 2 minus ions. Okay.
Yes,
So
sir.
if this is 2 into 10 to the power minus 2 molar, what will be this? This will be 4 into 10 to the power minus 2 molar, the double of it. According to the stoichiometry, you can see, right? And then this will be 2 into 10 to the power minus 2 again. I hope this is 100% clear to you.
Yes, sir.
Okay, very good then. If this is clear, take another question from my side. Hmm, just give me a moment. Yes. So the question is, question says, what volume of 0.955 molar, this is 955, okay? 0.955 molar HCl in milliliters in milliliters is required to titrate 1.33 grams of NaOH to the equivalence point. To the equivalence point. The equation is also given to you as Na. Sorry, sorry. Don't write this question. Wait. 1 point. Okay, you can do it then. Take it. NaOH aqueous plus HCl aqueous. Yeah, okay, write it. Gives you NaCl aqueous plus water liquid. Okay, please do it. The value for this is not 0.955. This is just 0.812. Okay, yeah. Now you do it.
Sir, 40.02, sir.
Okay, fine then. So how you have done that, I will just tell it quickly. So just a second here. Hmm. So you just did the number of moles of HCl equal to number of moles of NaOH here?
Yes, sir.
Yes. Okay. If you have done this, then it's good to go. Then if this is also clear to you, then there is some kind of a different question also which is available in the AP, which says that okay, you if you react X plus Y, na, some Z will be precipitated out. Do you know what you mean by precipitation?
Yes, sir.
Like it will be forming a solid compound. So what volume, like how much X and how much Y should be reacted so you get this much the required amount of precipitate. So this kind of questions can be there again. Okay. So like I will write one question for you here that what mass of Na2CrO4 is required to precipitate all of the silver ions all of the silver ions from 75 ml of a 0.100 molar solution of AgNO3. You have to solve it.
So, what is the concentration, sir?
0.01, 0.1 molar solution of AgNO3 is there. So you have to write a reaction on yourself first of all here. Getting my point? Okay. That Na2CrO4 will react with AgNO3 to produce something. That something you have to tell me.
Sir, 1.215.
1 point. So what is the equation you got here? First tell me that.
Sir, I directly use that moles of.
Okay, you mean to say that you have directly used like this something. Hmm?
Yes, sir.
Okay, but at least you should know na ki how much AgNO3 will be reacted with how much Na2CrO4, like in what
Like
stoichiometry.
moles, sir.
The
Stoichiometric.
stoichiometry, yeah. So for the stoichiometry purpose, we have to write the reaction first. Otherwise, your question will be wrong.
Okay, sir.
It might be 1:1. It might not be 1:1. Okay. So we know that Ag is Ag. It's present in Ag plus form. NO3 is present in NO3 minus form. Na is present in Na plus form. Cr is present in CrO4 2 minus form. Is it okay? And when you are doing this reaction, it's nothing but a double displacement reaction. You know the double displacement reaction, right? Like the metal from here will be
Yes, sir.
displaced by metal from here. Okay, so Na will combine with NO3, so it will form NaNO3, and Ag will combine with CrO4, so it will be forming Ag2CrO4. That means I have to take 2 over here, I will be forming 2 over here. Do you agree with me? To balance this equation.
Yes, sir.
Yes, so that means see the stoichiometry is 1:2, not 1:1.
Yes, sir.
You have to solve it again then.
2.43, sir.
Yes. This should this should be the value which you should get. Just let me check it once more confirmation.
Sir, should we explain Na2CrO4 also for?
Expand means?
Uh, I think no need, sir.
No, I didn't get you. What do you mean by expand actually?
Nothing, sir.
Okay. Yeah, so you told me the answer.
2.43, sir.
2.43 is again not the answer. How you got this value? Acha, okay, what you have done? Can you tell me quickly?
Sir, by taking 75 ml into 0.1 concentration
Hmm.
into 2, which is AgNO3. Hmm.
No, why in the beginning you are doing two? No, no.
So should we do by 2 or into 2, sir?
See, you are here up to a stage where you are saying that 75 ml of this will be reacted. This is giving the moles of AgNO3, right?
Yes, sir.
This is giving the moles of AgNO3. And now if this is the mole of AgNO3, how much should be the moles of Na2CrO4? How much should be the mole
Uh,
of CrO4 which is required?
X by 162.
I am talking about the moles. Moles. If this is the mole of AgNO3, which is 7.5, I can say
By 2, sir.
by 2. So 7.5 by 2 moles of Na2CrO4 is required. Yeah. To completely precipitate out this AgNO3. Do you agree with me?
Yes, sir.
Okay. Now we should find out the mass of Na2CrO4. So which will be 7.5 divided by 2 into okay, it's in ml na, so we have to divide by 1000 also here. So 1000 division will be also there. Okay,
Yes, sir.
so it will be 1000 division, and then you have to find the mass of it. So I'll be multiplying with the molar mass of Na2CrO4, which is how much?
162, sir.
1
62.
162. So just do it. How much you're getting? 7.5 into 162 divided by 2 divided by 1000. 0.6 grams, I
Yes,
guess.
sir. 0.6.
So
I
where are
did, but
you doing the
yes, sir.
mistake? That is, I want to understand that. Where are you doing the mistakes? It's
Yes,
not
sir.
a good question. See, I just found the mole of one species whose data was given to me. The data for AgNO3 was given to me. I found the mole of AgNO3. I then, according to the stoichiometry, I found the mole of Na2CrO4 and then just multiplied with the molar mass of Na2CrO4 to find the mass of Na2CrO4. Is it okay?
Yes, sir.
These kind of questions are not difficult, don't worry. We can do it using the stoichiometries or maybe some titration related things, okay? I just remember that whenever acid and base are reacting together, then number of moles of H plus should be equal to number of moles of OH minus, not the acid moles with the base moles. H plus mole should be equal to OH minus moles because the stoichiometry can be different. Okay,
Yes,
fine.
sir.
Okay, so this was there for today's class. The titration topic is also over. I guess this unit is almost done. Okay, just the thermogravimetry part is left, which is a very, very small part. One question in MCQ you can expect from thermogravimetry as well. Okay, we will discuss it in the next class in the beginning of half an hour. We will discuss that, and then we will move on to the next unit, which is atomic structure. Okay, so okay, till the
Yes,
time
sir.
you can leave, and we'll meet on Monday then. Bye bye.
Thank you, sir.